There's one little footnote that we should cover, and it's the fact that most computers actually don't do all of the steps of the DNS lookup, and instead, they make someone else do it. So sometimes we call your computer the stub resolver, and we call the actual machine that's doing these lookups the recursive resolver. So in pictures, it might look something like this. I'll go back to the text in just a minute. So instead of you making all the lookups yourself, what often happens is your computer is a stub resolver, and it asks the same question to someone else, a recursive resolver. The recursive resolver does all the work for you. So these 6 queries are exactly the same as the 6 we saw earlier. There's no difference, except that someone else is doing it for you. And once they have the answer, they just give the answer back to you. So this is basically the exact same thing we just saw. The only difference is adding these 2 steps, where instead of your computer doing the work, you make someone else do the work, they do all the work, and they just send the answer back to you. So you're a lazy stub resolver in this picture. So why would someone use a stub resolver? What's the point of this? One good thing is that the recursive resolver can handle requests for lots of people, so they can cache common requests. For example, if all of us in this room share a recursive resolver, then if I make a DNS request for www.google.com, and the recursive resolver does all the work, gets the answer, and sends it back to me, the recursive resolver could also cache the answer and remember that IP address, so that if any of you want to know google.com's IP address, when you ask the recursive resolver, it can just feed the answer right back to you, and it doesn't have to make a second set of DNS queries. So by caching requests, it makes the whole process faster, and it also reduces load on name servers, because now those name servers don't have to be bothered a second time when one of you asks for www.google.com. So it's a nice performance benefit. It pools all of our answers into a shared cache and reduces load on name servers. Now, one final little piece of bootstrapping we need is how to get the IP address of this recursive resolver. How do you know where to find one of these recursive resolvers? Well, remember when we talked about DHCP, we said that one of the things you get, in addition to your own IP address and the router's IP address, is the IP address of the DNS server. And we said that you should stay tuned for what that means. Well, now you know. The DNS server is that recursive resolver. And when you first connect to the network, you ask for a configuration, and whoever answers can tell you where to find one of those recursive resolvers. So that's a recursive resolver, and that's who you ask to do the queries for you, and they can hold a big cache of all of our questions and answers.